Okay, I'm going to do zeros of polynomials part 2. There's a part 1 that has already been made. So here goes. The zeros of a polynomial, also called the roots, are values of the polynomial that would values of x would make the polynomial equal 0. So I essentially need to set this thing equal to 0 and solve. Well, it's factorable, so I'll factor. How do there's the pair of factors of negative 725 that the positive 4 are negative 25 and positive 29. So I have x minus 25 equals 0, x plus 29 equals 0. So add your 25, and x equals 25. Subtract your 29, and x equals negative 29. So x equals negative 29 and 25. Those are the values of x that would make this polynomial equal 0. All right, similar idea here. Give all roots of this polynomial, so I want the value or values of x that would make the polynomial equal 0. So I need to solve x squared minus 60x plus 900 equals 0. Well, the pair of factors of 900 that the negative 60 are minus 30 and minus 30. Okay, the solution, so all I would really need to do is solve x minus 30 equals 0. Okay, I'm going to erase that and try to make it a little bit neater. X equals 0. And then I will add my 30. But however, there's more to it than this. Because the solution of this accounts for two solutions, or the solution of this accounts for two solutions of that. So I would describe this as multiplicity. Mathematicians would describe this as multiplicity 2. Okay? Reason being, this is an x squared. We expect two solutions. This solution would account for both of them. So add your 30, and x equals 30. So x equals 30, multiplicity 2. Okay, moving on. Here's two more. Find all roots of f of x equals x plus 11 times x squared minus 4x minus 165. A, with every multiplicity stated, B in the normal format. So the first thing I need to do is I'm looking for the roots, so I'm looking for where this polynomial equals 0. Okay, so I got x plus 11, and this also is factorable. The pair of factors negative 165 that the negative 4 are negative 15 and positive 11. So I got two x plus 11s. So that's x plus 11 multiplicity 2. I also have x minus 15 equals 0. Okay, so subtract my 11, and x equals negative 11. Add my 15, and x equals 15. So A's answer, every multiplicity stated, would be x equals negative 11 multiplicity 2, and 15 multiplicity 1. However, we do not usually write multiplicity 1. So the normal way this would be written is x equals negative 11 multiplicity 2 and 15. Okay, and then here's another one. X to the 7th, find all zeros of x to the 7th times x minus 14 cubed times x plus 26. So this would be x to the 7th times x minus 14 cubed times x plus 26 equal 0. So I could describe this as x equals 0 multiplicity 7, because that'd be x equals 0, 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 and x equals 0. Okay, so that's multiplicity 7. Okay, next I have x minus 14 equals 0 multiplicity 3. From the x minus 14 equals 0, x minus 14 equals 0, and x minus 14 equals 0. And then I have x plus 26 equals 0. So that's done. I don't need to do anything with this one, with that one. I need to do something with this one. That's add the 14. So x equals 14. Next I need to subtract the 26. And x equals negative 26. So x equals negative 26, 0 multiplicity 7, and 14 multiplicity 3. Okay, so this next one, consider f of x equals x cubed minus 11x squared minus 120x plus 1331. A, find the intervals where it's greater than 0 and where it's less than 0. And then sketch a very vague graph. Well, before I can do A, all right, I need to know where the zeros are. So I'm going to start just by doing do. First, before I can do this part, I need to know where it crosses over. So I need to know where it equals 0. So I need to find the zeros. So I need to solve x cubed minus 11x squared minus 121x plus 1331 equals 0. So I'm going to take out, it's a factorable by grouping, so I'll take out the x squared, I'll get x minus 11, third term is negative, and I'll take out the 121, and I get another x minus 11. So I have x squared minus 121 times x minus 11 equals 0. And that's further factorable as x plus 11, x minus 11, x minus 11 equals 0. So I'm going to scoot it over a little. And I have x plus 11 equals 0. And I have x minus 11 equals 0 multiplicity 2. So subtract my 11, and x equals negative 11. Add my 11, and I have x equals 11. Multiplicity 2. Okay, so I'm going to take this information and I'm going to create a number line. So x equals negative 11, and 11 multiplicity 2. Now that doesn't have any relevance when we're sketching our number line per se. I have negative 11, I have 11, region 1, region 2, region 3, and I'm going to test x plus 11, x minus 11, x minus 11 for positive or negative. Okay, I want to make this look somewhat legible and somewhat like Common English. All right, now, the first thing I'm going to do is, so region 1, I will let x equal negative 12, or negative 11.1, or negative 13, anything that is strictly less than negative 11. So I have negative 12 plus 11 negative 12 plus 11, negative 12 minus 11, and negative 12 minus 11. So I get negative 1, negative 23, and negative 23 again, which equals negative 529, which is less than 0. So region 1 is less than 0. Next, I'll do region 2. Region 2, x is 0. I'm going to use the original polynomial for that purpose. So 0 cubed minus 11 times 0 squared minus 121 times 0 plus 1331. Well, 0 minus 0 minus 0 plus 1331 is 1331, which is greater than 0. Okay? Region 3. I suppose I could fit it down there, probably. I wouldn't have any trouble if it wasn't for these the box that I have my document cameras stacked up on top of. Okay, so region 3, I propose x is 12. So 12 plus 11, 12 minus 11, 12 minus 11 gives me 23 times 1 times 1, which is 23, which is greater than 0. Okay? So, here's what I have. Negative 11, positive 11, this is region 1, region 2, and region 3. I put the Roman numerals a little higher than normal than previously, because if this region 1 was negative, I'm going to put the negative down here. Region 2 is positive, I'll put the positive up here and the positive up here. So f of x is greater than 0 at, I'm going to need to move this over, looks like. Okay, the document camera is going to move. Be forewarned. So f of x is greater than 0 from negative 11 to 11, non-inclusive, union, 11 to infinity. Okay, I'm going to try to write that a little bit more legibly. So 11, comma, infinity. Okay, that open dot means that it does not include 11. So f of x is less than 0 before negative 11. So negative infinity to negative 11. Negative infinity to negative 11. Now that was A. Now let's do B. So negative 11, about the same distance, positive 11. So it's negative before, negative 11, positive in between, but make sure you get back down, time to hit the 11, and then back up. Okay. And let me get that out of the way, actually. And I'm done. Okay, let me darken that 11. Okay. Now, one thing I almost forgot to mention is that you might have noticed that at this place it crossed, at this place it didn't. Well, odd multiplicities, like an odd multiplicity of 1, is going to be a cross. Even multiplicities, it's going to be a bounce. Okay? And that suffices.